Thank you, and welcome everyone. So just by way of a quick introduction, my name is Vajrang Parvate. I head the product and R&D teams here at Onshape. My personal background actually is in mechanical and software engineering. And in my career, I've led software engineering teams in CAD for most of my career, actually at SolidWorks before Onshape. The network management domain, as it happens, it's a great fit for a cloud-based application like Onshape, and also the simulation domains. And my personal passion has always been to work with large data sets, looking at user behavior analysis, something I've done in most of my leadership roles over the last 15 years or so. And Onshape really is the confluence of all of these things coming together. So it's really, for me personally, it's been a great experience, being at Onshape and being able to work on all these things. So Onshape's primary audience is engineers, whether they're students learning to become one, hobbyists, startup companies, commercial users, enterprise level users, we've got them all. Onshape is an application with production level attributes, the capabilities, the kernel that it uses, its users, and obviously the data that the users generate. And this actually makes Onshape really well suited for researchers rather than using just a pure research platform that may not have all these attributes. And since CAD research tends to be on the applied side, sharing a platform with real engineers is a huge benefit. Here are some of the examples of real-world products that Onshape users have designed. There's bicycles, aircraft, automotive, industrial machinery, robotics, consumer electronics. You've got toys, marine applications, engines, optical instruments, underwater robots, and in one case on the bottom right there, even people designing their own homes and backyards. So as you are all probably likely aware, Onshape is a cloud-native SaaS tool, as Paul mentioned. And it's a CAD application with a built-in PDM that runs in a browser. So this enables having a single source of truth for all the CAD and PDM data. And this data is obviously queryable, is always accessible, and has an event trail guaranteed to be complete. Now I'll go through some of that in a bit of detail. For those who have used file-based CAD systems, might realize that not all of these attributes are easily accessible. You've got copies of data in multiple places, variations of that data. It's not always easy to access it. They may be firewalled off. Those kind of things don't happen with Onshape. Obviously, you still need the access controls in place to protect IP. But this makes it a lot easier to actually get to that data to begin with. Now, Onshape's extensibility comes from three fundamental building blocks. The first one is FEATURESCRIPT. The next one is its REST API. And the final one is the event trail, which is a full list of actions that the user or users may have performed within any given document. These three are key to Onshape in that they enable not only you as end users and researchers, but also actually to us, as Paul mentioned, to Onshape's own developers to build the Part Studio features and actually to understand user and system behavior. So when we release new features, we can see how they're being adopted, how we may have foreseen some of the use cases, maybe not in others, and it really helps us adapt and implement new enhancements in those features. First one, so FEATURESCRIPT is a programming language that we created that allows end users to create their own custom features inside our Part Studios. First thing is all of our native out-of-the-box Onshape features, such as extrude, revolve, sweep, all the ones you're familiar with in the toolbars, are built with FEATURESCRIPT, and the source code is available under an MIT license as a public Onshape document. So you can look at the source code, see how it works, make a copy and modify it for your own use if you want a slightly different behavior. In a sense, it provides a simplified modeling kernel that lets you work with a brep and allows you to put logic right inside the part regeneration in the form of these custom features. Now, your custom features will behave exactly like a native feature with the rest of the system. With regeneration, as I mentioned, measurement, cross-section, creating drawing views, all these kind of things, it just behaves exactly like a feature that we would have shipped. And then you can prototype algorithms with this and build domain-specific features and even create a CAD within a CAD, which is really, really powerful. That's a lot more than a generic toolbox. For example, if you look at the bottom right example there, if you wanted to model a Lego brick with native features, you'd have to create the cuboid, then you'd have to create the top studs with an extrude or a revolve, then hollow out the shell from the bottom, and then fill in all the shapes with the mate, and mate with the studs and so on. Instead, you can just write a custom feature that just takes the stud dimension, let's say 1x4, 2x6, 3x8, whatever. And then the custom feature can generate the complete final geometry for you with every detail filled in. That is really powerful if you haven't seen it before. Next up is the Onshape API. The Onshape API is a public JSON-based RESTful API. For anybody familiar with RESTful APIs, the Onshape API is exactly that. It allows you to open and create part studios, assemblies. You can modify them, query them for geometry, topology, mass properties, measurements, and so on. You can regenerate parts in different configurations. You can query the feature list for dependencies or sequence of edits users may have made, and then export that data in various BREP or visualization formats like STL, OBJ, and so on. And then, of course, you can also create a complete add-in in your own user interface that can be used directly by end users in their own documents. So just like the feature script that we use ourselves, the Onshape REST API is also used by our own user interface and mobile applications. So we make heavy use of our own API. So it's the same API that we use that you get to use. And then finally, the event trail. It's the full history of operations done to a document or by a user. It has, in this example, you can see it has the timestamp, the user and document ID, the kind of operation that was done, and in some cases, some additional metadata for each operation. Now, by design, the input parameters are excluded from the event trail. So for example, the exact radius of a fillet or the depth of a cut, those kind of things are not included. This is generally done to protect the intellectual property, since the design of the event trail is not meant to recreate the geometry from in the document. But still, the audit trail is incredibly useful to understand user behavior, who in a design team is doing reviews, who is doing edits, collaborations, task assignments, completions, how long modeling tasks are taking, and so on. You can analyze, if given a certain deadline, how close to a deadline the work is being done. If that behavior is actually leading to good or worse designs. A lot of research being done in this area, and this is something we use heavily internally as well. Onshape's enterprise tier, our highest paid tier, makes this data available to end users in an easy to consume form of charts and dashboards as a feature called Enterprise Analytics. This is actually also included in our enterprise education tier that we have. And then this is available to the administrators of the enterprise accounts as raw data in CSV format. So you can post-process this in Tableau, in R, in Python, your analysis tool of choice. So there's a lot more you can do with this data in this raw format. From the beginning, we've always treated researchers as an important use case for our public data. And that's reflected in our design in several ways. First one is that our public free plan that hobbyists and anybody can sign up for requires that all models that you create be public. And while part of the goal is to encourage professionals to sign up for a paid plan, the flip side is that free users generate data that's publicly accessible and that you can use for research. The reason you can use it for research is actually baked into our terms of service. All free users have agreed that their public data is available under the terms equivalent to the MIT license. And so Onshape itself is a huge repository of free designs. There are tens of millions of documents that are available. And obviously, these are of varying quality, but there are a huge number of good parametric models. And there's a lot of open source collaboration that happens in the design space using Onshape. Now, you can access these directly in Onshape or export them as a mesh or a BREP, either manually or using our API. Several research groups have done the work of extracting some of these Onshape public documents and its data and packaging it into a more digestible form for batch processing, so you don't have to redo some of that work. For example, the ABC dataset project led from NYU extracted and packaged up over 1 million Onshape parts. Of course, the models don't have all the information that's contained in Onshape, but I don't think such a large data set of CAD models has previously been public available at all. Next one, the sketch graphs project from Princeton and Columbia packaged up about 15 million sketches, including their construction order. So again, the CAD data was never previously available at such scale. You can actually, this is being used to train data for a machine learning model to automatically constrain sketches, because now it includes the construction order and these constraints themselves. And then finally, as an example, the Automate project, which released over 5,000 unique mates, their associated parts, all created by Onshape users. And the goal of the project was to automatically predict mating schemes that users are using. So there's a lot of data already available, And extracting huge amounts of data from Onshape obviously takes time and effort, even though we have a really easy to use REST API. But before starting that, see what you're looking for already exists. Because if you, please talk to us first, because if your request that you make end up looking like a denial of service attack, our ops team's job, which is to protect the service, they may shut you off. So please talk to us, but we're happy to help you if it's a research project that you want to do and doesn't have the data available. Now, these are just a few of the many examples and research projects that have been done with Onshape data. There's several more, and you're going to see more in the course of the day today. So as I mentioned in the beginning, with the applied nature of CAD research, makes it very easy to deploy custom features that you create or applications you write to millions of users. This personally is extremely exciting to me. So I hope I've whet your appetite a bit for getting your hands on Onshape, working with its CAD data at scale, and for doing extraordinary research work. So with that, I'd be happy to answer any questions if there's time.
We've got a couple of minutes, Vajrang. Thanks for that. So if you do have questions for Vajrang, please post them in the meeting chat channel, and I'll pick them up from there. I'm going to ask you one, Vajrang, which is sort of, with all of this data that we have and with the growth of things like OpenGPT and so on recently, what do you think is the future there? Will people be doing design? Will ChatGPT be doing designs for us anytime soon?
Yeah. I think that's a really interesting new space, quite exciting, quite frankly. The assistive nature, anybody who's tried out ChatGPT will have certainly seen it reduces the drudgery of all of the work, because once you have a design in mind, conceptualized in your head, the number of steps you currently have to go through to, okay, click the button, create the sketch, click plane, create the sketch, put the constraints, make sure it's fully constrained, then all of these steps are very likely to be automated, in possibly the near future. It's something that we have to figure out in terms of what makes it interactive in a way where it is also precisely specified. Because if you say, create a cube of, 4 by 4 by 4 inches, that's enough for a human to understand another human. But for a CAD system, you need more. Is it constrained to the origin? Is it centered on the origin? Which plane is it front, left, or right plane? That kind of thing. So the number of specifications required and the assumptions need to be made have to be filled out as well. So that's an area of research, quite frankly, might be exciting a lot of people in the audience today.